Okay, I think we're good. Quickly, I'm just going to review the trig functions. Derivative sine, the derivative is cosine x. Derivative of cosine x is negative sine x. And then tangent's derivative is secant squared x. Cotangent x's derivative is negative cosecant squared x. Secant x is secant x times tangent x, and then cosecant x is negative cosecant times cotangent. Okay, so now I will go to slide 8 or problem 8, and I'll work this. I'm just going to work a few of these and then see if you have any questions. So how do we take the derivative of f of x is equal to x squared sine x? Well, we're going to actually use the product rule. Which, recall again, is there we go. Had to get it in focus. The product rule is the derivative of the second function times the first plus the derivative of the first times the second. Then when we do that, we take each derivative. So we'll take the derivative of sine x, which recall is cosine x. I'm going to put it second, put the x squared first, and then the derivative of x squared is 2x. So using the product rule, the final derivative will be x squared cosine x plus 2x sine x. So I'll see if there's questions. Just send me a chat. I got it open if you have any questions. We're kind of under unusual circumstances this morning. Okay, so let's try this one. Is x to the fourth times tangent of x. And I'll let you try that one, see what you get. You can just send me your answer. And if you need help, just send me that. I'll give you a second to work it. I'll give you a hint. The derivative of, if you haven't memorized this yet, the derivative of tangent x is secant squared x. So that should help. and you can just use the caret symbol on when you chatted him, will work for the exponent. And we'll see if we do product rule again, you'll do derivative of tangent times x to the fourth plus the derivative of x to the fourth times tangent x. And the derivative of tangent is secant squared x. And you bring x to the fourth down. Notice in the PowerPoint, I wrote it as secant squared first and then x to the fourth, then I switched them around. It's just easier to have the polynomial term first, followed by the trig. So then on the second part, the derivative of x to the fourth by power rule is 4x cubed tangent x. All right, I'd like to do one more with the product rule. So we're going to do e to the x times cosine x. And again, we will use the product rule. Which, looking at our function, we have e to the x times cosine x. So I'm going to do, again, follow the product rule. So derivative of second times first, which will be e to the x, and then derivative of e to the x times cosine x. And the derivative of cosine is negative sine x. And derivative of e to the x is just e to the x. And I'm going to rewrite it again with the exponential function first, and I'll put the negative first. So that'll look like negative e to the x sine x plus e to the x cosine x. And if you notice in the PowerPoint, I switched the terms around. You can do that as well. Questions? Okay, we got someone else in. I am on section 3.3, and we're covering the derivatives of the trig functions. And we just completed that one. Okay, I'm going to go to the next one then. I believe I sent these out. Oh, I got a question. Hold on. Okay, that's all right. I kind of, because of the weather, and I had to go find a mask real quick. I didn't get it sent out till like, it was like 6 or 7 after. All right. Okay, let's look at number 11. I'll send these out at the end of class. Well, so we're going to actually show that the derivative of tangent is secant squared x. I just gave you that rule a minute ago. But it's actually not that hard to prove this. Because what you can do is use your definition from high school, basic trig definition of tangent is sine of x divided by cosine x. And then now what we can do is the product rule, or excuse me, the quotient rule. Yeah, so we can use the quotient rule. I don't need to write it down. So the quotient rule goes like you take low times the derivative of high, which is the top, and then you do high, which is sine of x times derivative of low, all over low squared. Here, I'll put it down. I can put it up here. So if you have if a function's in the form I'll put high over low, what you do is the derivative will be low times the derivative of h minus h times the derivative of low over low squared. And we learned the saying low d high minus high d low all over low squared for the quotient rule. So I'm going to finish out and simplify. First, I'll have to do these two derivatives. The derivative of sine is cosine. And the derivative of cosine is negative sine. And those are your rules from last Friday. So when you multiply cosine by, I'm going to simplify the top now that I gotten these two derivatives taken care of. So cosine times cosine is cosine squared. Sine times sine is sine squared. And because of negative, you have a negative times a positive, or negative times a negative, it will be positive. I'm going to rewrite the bottom as, by the way, in trig, when you square cosine, you write it this way, cosine, and then you put the little 2 there. I sort of wish I would have done a trig review at the beginning of the year. Usually I did, and I just didn't think to do it this year. But there's a rule in trigonometry that goes, the Pythagorean identity, cosine squared x plus sine squared x is actually equal to 1. And that's because of the unit circle, basically, because if you think about it, if you square the x squared plus y squared, and then you have a radius of 1, it's like almost like the equation of a circle. Anyway, this is one of your main Pythagorean identities. So the top is equal to 1. And then if we have 1 over cosine, that is equal to secant. So we were able to show it, that the derivative of tangent is secant squared x. I'll leave that up there if you want to copy it. Okay, I want one more example to do, and then I'm going to take questions. Because I'll probably, let me work this one out, and I'll probably actually stop the record. It'll probably be enough for the video, and I can send it out to people that missed today. All right. So number 12, we're going to do the same thing with cotangent, essentially. Show that the derivative of cotangent is equal to negative cosecant. Okay, I'm going to do the same trick. I'm going to make y or f of x, whichever one you want to use. I'm going to make cotangent equal to its identity, which in this case is cosine of x divided by sine of x, instead of sine x divided by cosine x, which is tangent. And then again, I can apply the quotient rule here and get the derivative. So I'm going to go ahead. In case it's first, if it's easy to read the PowerPoint, I'll have both of them up. So we'll go low, which is sine x, derivative of high, which is derivative of cosine, minus high, which is cosine, times derivative of low, which is derivative of sine x, over sine, and I'm just going to go ahead and square it that way. Now I'll apply the rules. We're applying basically the same rules. It's just flip-flopped. This is negative sine. The derivative of sine is cosine. So this will turn out to be sine of x times negative sine of x minus cosine x times cosine x. Now I can bring the bottom down. And then again, I can rewrite these as squared. So it'll be negative sine squared, because you do have a positive times a negative and a positive times a negative in both cases. So we end up with negative sine squared x, negative cosine squared x, but I can simply factor out a negative, as you can see in the PowerPoint. And if I factor out a -1 or a negative, I get sine squared over cosine squared. And that should be sine squared, I forgot it. And again, this is equal to 1. Sine of x times cosine x is equal to -1, or to 1, which will be -1. So I end up getting -1 over sine squared x. I'm just going to factor the negative out. You can just bring it outside the fraction, because the top will be -1. And remember, 1 over sine is equal to cosecant. So we got it. Remember, 1 over sine is equal to cosine x. So we can square to 1. The top is still 1 squared. The bottom is sine squared. So that would be cosecant when we're done. And probably what I'm going to do on Tuesday is go more over this and then review. I don't know if we're ready to go on to the chain rule yet. I might just review derivatives, but in any event, I will review some of this on Tuesday. So that wraps up the material. I'm going to give some time for questions. Let me stop the record, because I don't want this video to get too long, because it makes it really hard to upload it. So let me stop the recording.